Okay, so we have another revenue one. Again, I'd strongly suggest that you try this. Make sure that you try this before you watch this solution, just to see if you can figure it out. Definitely practice makes perfect for these types of questions. The first thing that we consider when we recognize it as a revenue question and what price will maximize the revenue, definitely a revenue question, is to say we know that revenue is price times the quantity sold. And so let's start to analyze that a bit for this particular one. So I usually like to start off with what is our revenue at this time? And so we look back and we say, well, the price at this point, currently what they're doing is $15. They're selling it for $15 per ticket, and they're generally selling 250 tickets. All right, so we can work that out if we wish, but bottom line is that's where they're currently sitting for revenue. And the question is, could they do better if they made some adjustment to the price? There certainly sometimes when you increase the price, you lose enough customers that you do not want to touch the price. But in some cases, you can determine that is actually a bit of room for movement there. And so that's where we're heading next. So we want to say, well, the revenue as it varies would look like this. Well, again, the price, we start with our base of 15, and we're told that for every $2 increase, so $2 times the number of increases. And I'm going to make a note of that, just so we don't forget at the end that we suddenly write down X and can't remember exactly what that was standing for. So is the number of increases. And we can even say of $2 if we want. So there we go. Now, what does that do if we increase the price? What does that do to the number sold? So we're told that starting with our base of 250, we would lose 20 customers for every increase. And so we'll just put the X there. So we gain $2 for every increase per ticket, but we lose 20 tickets per every increase. So what does that look like to us as far as a revenue point of view? So off we go to Desmos. And again, showing our work means doing a quick sketch of what we saw in Desmos. And so again, doesn't have to be perfect, but it should kind of show what's going on here. So what we can do is we can say the number of increases here are X, and our revenue is our Y. And if we have no increases, that means we're staying exactly where we're at right now. So that's that y-intercept right there. And so the vertex is definitely of interest to us. In other words, that is where we see a maximum revenue. And so we can say that revenue max, or the vertex. And what we can do is from Desmos, we can identify that as 2.5 and 4,000. All right. So we can make a maximum revenue of $4,000 if we were to have 2.5 increases. Now, again, being organized means that you're not one of those people who just writes down, oh, the answer must be 2.5. 2.5 what? Oh, must be $2.5. Are you saying the price of the ticket will be $2.50? It was originally $15. So this is where you stop and you say that does not make sense. Okay, this is where it was good we were organized, because now what we can say is the new price at that maximum was the original price, but we added 2.5 increases. And each increase was how much? Well, increase of $2. So there we go. So 15 plus 2.5 times 2 is 5. So that means that our price for maximum revenue would be $20. And if we were asked, what is that revenue? Well, we can go right up here and we can identify that as 4,000. So there we go. All done.